Right, oh God, I said it again, right. There was only another 5 resistors, so they're all in position now and all nipped off. So now we can move on to the more exciting capacitors. Now you don't need a calculator for the capacitors, especially the, well, any of them, the ceramics or the electrolytic, because all the details is stamped on them. So, for instance, just looking at the circuit board, these are positions for electrolytic capacitors. They're polarized, so they've got to go in a certain way. These are ceramic capacitors and they can go in any way round you like. So when you're looking at it, you can see where the electrolytic capacitors go and where the ceramic ones go. One there, one there, one there, one there. So again, their value is marked on, printed on the board. Unfortunately, this is, I can't make up my mind which way to do this. Go that way. The values are marked on the board, so C4 there is 30 UF. So is that C5? That's the same, and that's the same. It's impossible for me to read them through the viewfinder, but you get the idea. They're all marked. There we are. That's C8 104. So I'm going to have to turn it around again because I'm working this way. We'll start here and C17 is 104. So we find an electrolytic capacitor, and can you see? No, you can't see. It's marked 104 in printing, so that's easy enough. So all you do is pop him in, and as I say, these are not polarized, they go in either way round, makes no difference. So drop them in the same as you drop a resistor. Get it as close to the board as you can without straining it, and just part the legs. So that looks alright. Next one, C13, that's a 104. That's easy then, so you just get a 104. No calculator needed. 104, pop him in. I try to keep them centralized so they look tidier. Spread the legs. You can't see what I'm doing. Don't have to be closer or further away. Right. Again, I'll go through all these ceramic capacitors. I'll put all them in. I can solder those two in and we can see that in operation. Dab of the old flux. the iron's been sitting for a minute, so I just refresh it by sticking it in the flux and in the tip cleaner, and then we can put a bit of solder back on. I think I'll just hold these with my finger to make sure they're right. They tend to get a bit warm if you're not careful. There we go, there's one soldered. A bit more solder on the iron. And there's the other soldered. Just want to keep him vertical. One. Two. Done. And then we can just nip him off. And that's the start of the capacitors. Seems to be a few more of them than there are resistors. Done. Move on. So what can I say instead of saying right? Left. Oh, one other point. At some time you might need a solder sucker, and this is the, out of all the ones I've bought all the cheap ones and everything you see on eBay. I've bought every one you can think of. This again came from Farnell, I think. It's Japanese, and it's a solder sucker. It's totally made in aluminium, and it has a silicone tip, replaceable tip, and boy does this suck. You just obviously flow the component you want to remove. Because it's silicone, you can push it up against the soldering iron and twang, and it usually removes everything in one go. Just a little aside. Don't know if you can see that. Anyway, they come from Farnell, I think. Made in Japan. It's Engineer SS02 solder sucker. Brilliant. Right, just mention that. Now I'll move on and I'll sort out these electrolytics. You can see how many resistors we've got spare, because we've put all them in now. I'll do the electrolytic. I will do the ceramic capacitors, and I will come back. See, I didn't say it. There we go. All the capacitors are now in place, but I just noticed as I was trimming the legs on the back, there's one just needs a little bit of attention. It's always good to go over the board to check that you haven't missed anything. I hadn't missed it, but it only got half soldered. That's it. And now it's all soldered. Right. Oh God, I have to find some other bloody word. Oh, I swore now. Oh dear, 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 dear. Right. Cali Toto, and that's as far as we've got so far. We've got all resistors, 10 of them, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 capacitors all in place. I don't think I've missed any, but I have. I can see one straight away there, 472. Right, 472. I can see it, I've got it. There we go. 472. We're going to pop that in. Probably younger people with younger eyes will have spotted that a mile off and said, "Look at that, you silly old sod, you've missed one." Bit of flux on the back. I'll just refresh the soldering iron. And there's one. So that was 14, was it? I don't know if anybody's counting. 14 capacitors. There we are, that one's in. We'll have one quick look over to see that we haven't missed any more. Snip off the wires. Lovely them are. Right close to the board. Right, quick scan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think I got them all. Now, there's one thing I just want to mention is on the other one I built that didn't work first off, as I say, for a living I'm an auto locksmith, and part of the auto locksmith trade is electronics in respect of removing chips from circuit boards and reading them, reading the data off and reading the dump files, and then producing a transponder that will start a car. So I'm pretty fluent, pretty not knowledgeable, but I've taken hundreds of components off circuit boards, surface mount and through the hole, to read the IC chips. Now with this, when I finished it, it didn't come on. I think I got the LCD came on, but just static. And of course I'd made a mistake on the board. I'd think it was that resistor there, whatever it is. I'd put 10 kilo ohms instead of 10 ohms. Because I'm half blind and 900 years old, I made a mistake. I swapped that. I got the radio on, but it was very, very quiet, and I spent ages double checking, triple checking every component I'd put on, and other than the one I originally found, I couldn't find a problem anywhere. So it was receiving all right. So the FM chip, what's it called? The CD 2003 was working, because I could hear it, but it was quiet. And everybody else's video I'd seen, they put them together and it was blasting out, it was jumping about, bouncing. So I went through mine and through mine and through mine. I couldn't find anything wrong. Anyway, in the end, what I did was I bought a couple more 2822 amplifier chips. That one. Now, as I say, I've soldered loads through the hole and surface mount of chips. These chips tend to be pretty bulletproof. You get some of the Motorola QFPs and so on, they can be a bit heat sensitive, and I use a heat gun to remove them, but with these sort of things, they're pretty bulletproof. And you've seen the method I use for soldering. I only touch the component for a few seconds, not even a few seconds, to flow the chip in. I have no problem doing that. It's a job I do week in, week out. Not particularly through the hole these days, they're all SMDs, and I'm working with them, much smaller chips. Some are like so small, I have to use an eyeglass to see the damn things. Anyway, having said that, when I received my 2822s, I changed that one out, and immediately I'd got full volume. It was working as I expected. Now I can't see that I damaged that chip soldering it in. I certainly didn't damage the receiver chip, so I doubt very much if I damaged that. That's why I'm saying I think I had a faulty one. Anyway, to make sure we don't have those sort of problems again, what I've got is I've got some carriers. So I'm going to put all the chips on this board, as I have with the other one, in carriers. So there definitely won't be any heat transference to the chip that might cause it to go brown bread. So what I'll be doing is soldering these carriers on, and then the chips just push straight into the carrier, so you can take them out if you want. So I'll do that to both chips. I think I did it to the other one, but that's why the other one didn't work, and it could have been me. I can't definitely say it wasn't me, but with all the soldering I've done, I've never killed a chip that I can think of. I once had one blank while trying to read one in circuit, and since then I've never ever read a chip in circuit. I've always removed them and read them in a reader and then soldered them back. So that was many years ago that happened to me, and I made sure it was, again, I don't think it was particularly my fault. The equipment I had said read in circuit with a chip, with a clip, which I did, and it didn't, it wiped. So as I say, ever since then I've always taken them out and put them in a external reader like a B-prog or something like that to do me programming. Anyway, that's by the by, nothing to do with this job. I was just pointing out one little alteration I'm going to make. I'm going to put a couple of carriers on it to rule out the possibility of damaging a chip. I don't think anybody will damage a chip soldering them on. I've never damaged one before, but we want to rule it out. So that will go there, and this one will go here. If you want to do this, these are absolute buttons on eBay. I might have to do a bit of modification to that one to get him in. Oh no, I won't have to do any modification. I've got the wrong one. Too many legs. That must be that's an 18 and I want 16, so I'll just go and find another one and I'll pop it on. So what's next? We'll go for the electrolytics. Again, with the electrolytics, they are printed on the side what they are. So the ones in my finger now are 470 microfarad. And listen to that clown. They get a dump valve and they think they can drive. Right, so the 470 UF goes in the middle here, and as well as a circle with it being marked positive and negative, it also shows it lying down. So that's what I'm going to do. For those that don't know, all capacitors, electrolytics are marked with a negative side, and that's the band on the side. The other leg is positive. So on the PCB we've got a positive sign and we've got a negative sign. I can just see that my battery's going to die, so I'll stop this and commence with another battery.